talking about arcs today. You guys remember what an arc was?
Yep.
Yep, sure. Let's see here. Let's do diameter. Yep. Okay. Part of the circle. So let me put some letters up here. Call this C, D, E. All right. Okay. So what are some arcs in the circle? Okay. DC, AB, BC. Right. All those arcs.
Could just E be an arc if it goes all the way around?
Could just what?
Like E?
No.
Okay.
So if you want to say the whole circle, you would just say circle M. And by the book's definition, that would be an arc. Okay, what if I want to go from like C, if I said AB, that would be from here to here, but what if I want to go the long way around from A to B?
AEB?
Okay, right. You just need to use a third letter. So you could call it A, E, B, A, F, B, A, anything, B, really. That just shows that you're going the long way around. Okay. These little arcs that are less than 180 are called minor arcs. And if you have to use 3 letters, if it's 180 or more, use 3 letters, it's called a major arc. Big arc. So if I want to do a semicircle, you guys know what a semicircle is? Half the circle. Then you need to use 3 letters, because if I just said arc FC, it's unclear what I'm talking about. Could be either way. So if I want to say the top half of the circle, I would say arc FAC. Or the bottom semicircle. Alright, what would these 3 angles in here in the middle add up to? What should these 3 angles in the middle add up to?
360.
360. How'd you know that?
Because the 360 is all the way around.
Right, 360 is a full circle, full rotation. Right? So go all the way from there to there. Should be 360 degrees. Okay, what would you guess this angle right here is?
80.
BMC. 75, 80. Probably 80. I can check. Oh, actually, I might have one on here. Let's get the toys out. 70. I was wrong. Okay, how do I get rid of you? Go away. Where is it?
It's a fit.
Oh, whoops, I think I missed. Okay, now. Alright, anyways, pretend 75. Okay, this is called a central angle because it's in the center of the circle. It goes from the center. Okay, this arc from here to here has a length, right? We could get a tape measure out and measure it. It might be about a foot, 12 inches or so. But it also has a measurement, okay? And it would be 75 degrees also. So a central angle has the same degrees as the arc it intercepts. 75, 75. What does this 75 mean? It just means, it kind of gives you an idea how much of the circle you're using. So from here to here is 360, all the way around the circle should add up to 360, okay? They're just kind of, they're related to each other. They're same idea. I think it's tomorrow. Yeah, tomorrow we're going to actually figure out a way to measure the length of the arc. But today we're just talking about degrees. How many angles is it? So the length of the arc of a circle could be anything. Could be a mile, could be 2 inches, whatever. Depends on what circle we're talking about. But the degrees can only add up to 360 in total. So it just kind of gives you what fraction of the circle are we working with. Oh. Let's see if I can draw a good one here. Okay. This angle down here, angle BFC, is called an inscribed angle. Whoops, BBC. British Broadcasting Channel. Angle BFC is called an inscribed angle. Well, you guys remember the word inscribed? Gosh,
Yes.
my brain's all over the place. Like if you draw a triangle inside the circle, that would be an inscribed triangle. If you draw a square outside the circle would be inscribed. Just means drawn inside. Literally means in drawn. Inscribed. So, how do you think this is gonna, let's see if you guys can guess, probably not, maybe not, I don't know, maybe. How is this angle gonna relate to the arc it intercepts? The central angle is exactly the same thing as the arc. How do you think this angle compares to the arc? Justice, I'm paying attention. Any guesses? No? Well, it turns out that the inscribed angles are always half of its arc. Okay? Because if you think about it, like this one, if I pulled this point over, it would stretch it out and the angle gets smaller. It just always ends up being exactly half. So this would be 37.5 degrees. Which is half 75. Any questions on that so far? So if I were to draw another 75-degree angle down here, we would know that this arc would be 75. The lengths of the arcs would have to be the same thing, right? It's kind of obvious, I think. Well, I think so. Also, yeah. Everything would be equal. Yeah, it's kind of obvious. I think it might be about done, actually. Yeah, that's all I can think of for now. I think I got it all. Alright, so we're doing page 385, 1 through 13, and we'll try 16. Give that a shot.